Okay, so the other name for dimensional analysis is unit conversions. Basically, it's math with a purpose. Okay, if you want to know how, let's see, there's a 26-mile run coming up, right? No, it's a 26. What are the 26ers? Are they? They're 26Ks, right? They're the marathons, right? 26.2 miles. So maybe we're really interested. You know, you're getting bored during the marathon, and you want to know how many feet is this? Okay, so as you're doing the marathon, you whip out your calculator, you whip out a pencil and paper, and you as you're running, you just kind of start writing this down. It helps to focus the mind on something else, right? Okay. Yeah. Starting the recording again. What it's called is called dimensional analysis, and dimensional analysis uses equivalence statements. Okay, equivalence statements are things like this. Like 1 mile is exactly 1.609 kilometers. Okay. Another thing that 1 mile is it's 5,280 feet. That's an equivalence statement. 1 inch is exactly 2.54 centimeters. It's kind of cool. That works out perfectly. And we know that 1 foot has 12 inches in it. Okay. Each of those 4 things are equivalent statements. Each of these can wind up being turned into a conversion factor or a ratio, which I'm going to show you on the next slide, that can be used to do dimensional analysis. So the question is, do we need all these? You have a variety of places that you can go and find equivalent statements to use. Do you guys know any of them? Okay, Google is a nice place to go, yeah? I'll show you that in just a second. Another place, your Porter Planner has a page in it of equivalent statements, okay? The other place is the very back of your textbook. If you open up to that last page on the inside cover, it's either on the inside cover or it's on the last page. I was just looking at it this morning, so I should know, but one of those 2 places, it's there. Okay, so no, you don't need to know these. The ones I need you to know are like how many centimeters are in a meter. You guys know how many centimeters there are in a meter? Right, because you guys know the metric prefixes, right? If you know the metric prefixes, you don't have to look those things up. Okay, so here's how we Google it. By the way, this doesn't work on tests or quizzes because you're not going to get to do it this way. But if I wanted to know how many feet are in a 26.2 mile, okay, Google tells me. It does it automatically, right? 26.2 miles is how many feet? Might be better to ask it how many feet 1 mile is. 1 mile is 5,280 feet. You can change these units, anything you like. If you want to know how many feet or in a kilometer, you can do that. Okay. The problem is that Google will provide you with an infinite amount of possibilities, whereas when you look in an actual chart, you're going to have to use specifically what's on the chart. As far as making a conversion factor out of these equivalent statements is concerned, it's really easy. We know 1 mile is 5,280 feet. We could write 2 conversion factors, 2 ratios from that, right? We could say that 1 mile over 5,280 feet is a ratio. We could also say it the exact opposite way. We could say 5,280 feet over 1 mile is a ratio. So for every equivalent statement that you've got, you can come up with 2 ratios. All right. Basically, the dimensional analysis part is that it's a very logical pattern of events that helps us to convert from one type of unit to another kind of units. Basically, in a word problem or in any sample problem that we're given, we'd be given some given units, and we'd be asked to convert it to some other desired units. We do that through a ratio that we set up as a conversion factor. The whole mathematical concept of this is that what's at the top of a ratio will wind up getting converted by what's on the bottom of another ratio. I can kind of prove that by saying something like this. What's 2 times 1/2? 1, right? Isn't essentially what's happening here, the 2 on top and the 2 on the bottom are canceling, turning into 1s, and we get 1. What's 4 times 1/4? Still get 1, right? The 4 and the 4 are canceling. You get 1 and 1 there. So 1 times 1 divided by 1, we still get 1. Okay? So what's going to wind up happening here is the units are going to cancel also. And I'm going to show you that in the next sample problem here. The question is, what is this used for? Why do we use it? Here we go. So, for example, we might be interested in knowing how many feet there are in 145 miles. I bet you guys woke up this morning and you asked that question, right? How many feet are there in 145 miles? Because you're thinking about doing like a 6 marathons all at once. All right. So the basic methodology is this: when you're doing a conversion, you start out with what's given in the problem. The problem tells you we've got 145 miles, right? And we're going to multiply that by some ratio. And hopefully that ratio is going to help us to convert into feet. Okay. Now the rules for this are pretty simple. The units that are up here have to be the same as the units that are down here if we want them to cancel. So I'm going to put miles on the bottom. Do I know any conversion factor that has miles in it that also has feet in it? Right. All right, that's right. So 1 mile, I'm going to put feet up on top, and I'm going to say that 5,280 feet is in 1 mile. Now, if you didn't know that fact, you might have to look it up in a chart, right? I think we mentioned that at the beginning, though, right? It's in your notes right now. Okay, so the units of miles and miles cancel with each other, just the same as the 2 and the 2 and the 4 and the 4 canceled on that last slide. Okay, so that's going to leave me with only units of feet at the end, and the math is going to be 145 times 5,280. Grab our handy-dandy calculators here. 145 times 5,280. Ooh, and we're going to consider sig figs, right? We're doing math here. What kind of math is this? It's multiplication and division, right? Because we're dividing by 1. So do I concern myself with place value or the number of sig figs? Good, you guys have this, all right? So how many sig figs am I going to want? Okay, here's something interesting. How many sig figs in 145? 3, right? How many sig figs in 5,280? No. It's an exact number. So we're going to say infinity here, the way it's being used. Because it's a conversion factor. Because it's an exact value. Conversion factors are exact values. So how many sig figs in 1 mile? Infinity. Okay. So guys, when we're doing dimensional analysis, are any of these middle steps going to have sig figs that are usable? So because we need 3 sig figs, the calculator tells us, holy cow, 765,600. I only want 3 sig figs, so I'm going to round that up. 766,000 is the measurement is the value we're going to get. And again, that's because this 145 miles was measured, that we can round to 3 sig figs. Let's take a look at this. You want to try this one yourself, or should I lead you through it? All right, sure. All right. Go ahead and try it yourself then. Okay. So we have 1,430 inches. And I usually do this. I usually write centimeters over here because eventually I want centimeters and it helps me to remember. Sometimes I get lost in a problem because it gets real long. and it helps me to remember where I'm going. So in this case, I'm not going to get lost because inches to centimeters is something that either A, we know, or we just wrote down in our notes, 2.54 centimeters in an inch. Inches are going to wind up canceling because they're on the top and the bottom. And it's going to be 1,430 times 2.54. Did I write 1,430 right? No. I need a decimal there because that has 4 sig figs. Okay, there's infinite number of sig figs in 2.54, and there's an infinite number of sig figs in 1 because that's a conversion factor. So I'm going to need 4 sig figs. The calculator tells me 3,632.2. If I want 4 sig figs, I'm going to grab the first 4, use the 2 to round, and the answer is going to be 3,630, whoops, for some reason it's not writing, 2 centimeters. So that's what we're going to get there. We're going to take this. We have to start with 3.775 kilometers. Uh-oh. All right. The first conversion factor, they tell us 1 mile is 1.609 kilometers, right? We want kilometers on the bottom, so I'm just going to put kilometers on the bottom. That means that the number that goes with kilometers goes on the bottom. Okay. I can put miles on top. 1 mile is 1.609 kilometers. That's what the equivalence statement says, right? That's what my conversion factor is going to say. So kilometers and kilometers are going to cancel. Not there yet. I have to convert miles into feet. Fortunately, we know that one. You guys all have that one memorized? No. Okay, that's fine. 1 mile is 5,280 feet. Okay. Again, I've got equivalence statements here. So there's an infinite number of sig figs, an infinite number of sig figs, an infinite number of sig figs, and an infinite number of sig figs. That means that I have 4 sig figs at my starting number. That means that's how many I'm going to want at the end. What answer do we wind up with here? Is it 1,390? 12,390 is a total of 4 sig figs. And is that okay? 12,390 with no units? Feet, right? We need to put the letters FT there. Recording. There we go. We got 45.6 feet. And we can convert feet to inches because I know how many inches there are in a centimeter. Part of this is kind of planning out your problem in your head as you're going along here. I know 12 inches is 1 foot, so that feet and feet cancel. As far as my next thing is concerned, I know that inches and centimeters. I know that 1 inch is 2.54 centimeters. You'll end up using that a lot. You'll have it memorized. Inches and inches will cancel, leaving me with centimeters. Again, these are conversion factors. They've got an infinite number of sig figs. So when I look over here at my beginning number, the measurement looks like it's got 3 sig figs to me. So 3 sig figs, the calculator spits out 1,389.888. I'm going to round that to 3 sig figs, so 1,390 centimeters seems like a good answer.